Okay, so far we have the data standards that utilities can use. We have a performance index where they're going to get a much better idea of what their pipeline system is really like. So I guess the next question is, they take all this information they have so far, how are they going to predict the remaining asset life?
Yes, Walter, you are right. The phase one we have done is the data standard, and phase two is the robust performance index. Then comes still this one is not with the time. This index is today. If I go and collect the data, it will give the health index or performance index of the pipe network today. But most of the utility want to predict, because if you have a minor crack, you are not going to fix. You want to know how long this crack is going to last. So that's the third phase of the project, is to develop a robust prediction model. What I mean by robust prediction model is we are not developing a model just to predict a failure of the pipe. Of course, failure comes at the end, but basically what we are predicting is based on the index, robust index, which is scale 1 to 5, we are predicting the entire performance throughout the life cycle so that we can intervene. If a utility has a level of service defined like up to 2.5, then we can come and intervene here and do some rehabilitation, then the curve will start deteriorating from that point. So that's the beauty of developing a model to predict the performance and condition rather than just predicting the failure. Because predicting a failure is very difficult to know which pipe in the network is going to fail when. It will give a general idea, like 60% of the pipe is going to fail, but when you go to the project level, which pipe is very difficult. But if we develop this from node to node in the wastewater manhole to manhole, then we can precisely say which pipe is going to fail. So this phase is, current research is going on, and we are working with the various utility to have their data. The challenge is most of the utility doesn't have time-dependent data. If we have good time-dependent data, then it's much easier to develop the probabilistic model. But there are many other models which can be combined, and as utility goes on, they collect data, then this model can improve and it can be updated.
I think this is going to be a really interesting exercise for these utilities, but can you please explain to me what you mean by probabilistic model?
Yes, Walter, that's an interesting question. In this whole modeling, especially prediction modeling, there are three models which most of the either consultants or academic they use. One is called deterministic model, the second is the statistical probabilistic model, and third is now advanced mathematics, which is fuzzy neural network. Deterministic models are good, but the challenge is if you develop like a corrosion growth in the lab, it can predict the corrosion growth and failure of the pipe. But if that circumstances or scenario doesn't fit in a real world, then that model cannot predict precisely. So that's the challenge in deterministic model. Probabilistic is good because that's based on the real world data. And each utility can collect their own data. The only thing is if you don't have enough data, then that probabilistic model will not have a great confidence in that. The third one, which is also becoming very popular, is combining the heuristic knowledge, fuzzy, and neural network, which is a learning. As more and more data comes in, the network can learn and predict better. So that's the basically three, and we will be looking at all these three. Maybe in some way we can combine for certain kind of a pipe or scenario.
Great, thank you.